Asperitas, which translates to rough and uneven, is one of the rarest cloud forms on record and the only one to be formally added to the World Meteorological Organization's Cloud Atlas in nearly 70 years. Given the recent discovery, little is known about how or when Asperitas clouds form, although we have some theories. So what distinguishes Asperitas clouds? Why hadn't we noticed them earlier? And in the future, could their discovery provide a blueprint for identifying extremely rare weather events? Join me today as we look at stunning high-definition images of Asperitas clouds. Learn what scientists believe is causing their dramatic appearance, and consider the exciting implications of this unusual convergence of citizen science and trailblazing research. Before we begin, don't forget to like and subscribe to this channel for more intriguing videos like this, and be sure to watch this video to the end. Therefore, anytime we upload a new video, you will be notified so that you won't miss out on interesting videos from us. Let's begin, without further ado. Asperitas, formerly Undulatus asperitas, is a cloud formation popularized and proposed as a type of cloud by Gavin Preter-Pinney of the Cloud Appreciation Society in 2009. It is the first cloud formation to be added to the International Cloud Atlas as a supplementary feature since Cirrus Intortus in 1951. The name roughly translates as roughness. The clouds are similar to undulatus clouds. Despite their dark and stormy appearance, they almost always dissipate without forming a storm. The foreboding-looking clouds have been especially common in the plain states of the United States, most often in the morning or midday hours following convective thunderstorm activity. Jane Wiggins, an amateur photographer from Cedar Rapids, Iowa, took a photograph from her office window in 2006 that she described as looking like Armageddon. She forwarded the image to the Cloud Appreciation Society, which published it on its website. The photos sent shockwaves through cloud watchers, who suspected it could be evidence of a previously unknown cloud formation. Other amateur hobbyists using the Cloud Spotter mobile app began sharing their images, sharing weather conditions to watch for, and assisting others in seeing it for themselves. The Royal Meteorological Society took notice of this and used dozens of photos collected by the Cloud Appreciation Society to prepare a case that they sent to the World Meteorological Organization. After several years of deliberation, the WMO announced that, for the first time since 1951, a completely new type of cloud would be added to the Cloud Atlas, giving Asperitas clouds the unique distinction of being the only cloud type discovered as a result of digital crowdsourcing. But why was this so uncommon? And who decides what distinguishes a cloud form? Let us begin with a primer. Clouds are essentially liquid droplets or solid particles suspended in a planet's atmosphere. While clouds on other planets can be composed of methane, ammonia, or even sulfuric acid, the vast majority on Earth are composed of liquid or frozen water. And I'm glad we don't have a lot of the sulfuric acid variety. Clouds form when saturated air reaches its dew point, which is the temperature at which water vapor condenses into liquid due to cooling air or increased saturation from an adjacent water source under a given set of barometric conditions. There are 5 main types of clouds: stratus, cumulus, stratocumulus, cumulonimbus, and cirrus, which are further classified into different genera based on altitude. In addition to these primary categories, there are a variety of accessory clouds, clouds that separate from the original genus cloud, and supplementary features. All of these are formally classified in the World Meteorological Organization's Cloud Atlas, the international manual for cloud identification, which employs a linear nomenclature that has been in use since the early 19th century. The World Meteorological Organization is in charge of updating the Cloud Atlas, but revisions are extremely rare. Cirrus Intortus, the most recent new formation, was added in 1951. Asperitas clouds are now thought to be primarily a supplementary feature of stratiform clouds, which are low-elevation layered clouds with no vertical development, though Asperitas clouds have also been observed to be stratocumulus or altocumulus clouds. While the bases of stratiform clouds are generally flat, they tend to develop significant features at the top due to changes in wind and temperature. This is extremely common, and you've probably seen it if you ever looked out the window of a plane. The highly developed structures at the bottom of Asperitas clouds distinguish them. The Cloud Appreciation Society, the University of Reading, and McGill University published a paper in 2017 attempting to describe the characteristics and causes of Asperitas cloud formation. The authors define Asperitas clouds by their rough, somewhat wave-like cloud bases, which lack the smooth undulating shape of the possibly related undulatus cloud type. The authors hypothesize that Asperitas clouds are likely formed by weak oscillatory activity based on their semi-wave-like characteristics. There are several possible explanations for this. One example is orography, which is the wave-like movement caused by airflow over mountainous terrain. Other causes could include horizontal wind shear, convection, the exchange of matter or temperature between fluid bodies, or atmospheric gravity waves. In case you're wondering, a gravity wave is not the same as a gravitational wave. As much as I enjoy space-time physics, we're not talking about massive ripples in the fabric of space-time here. A gravity wave occurs at the boundary between two fluids when a force disturbs the equilibrium and gravity attempts to restore it, resulting in a back-and-forth movement or wave orbit. Tsunamis and changing tides are two well-known examples of gravity waves. You've probably seen the effects of gravity waves on clouds. These are called undulatus clouds. I'm sure you've seen cloud formations like this before from the ground. The view from space is equally breathtaking. However, Asperitas clouds have a rough appearance that indicates unusual instability at the cloud base. These aren't smooth and wave-like, like the undulatus cloud type, but have a chaotic formation like the stormy ocean. While stratiform clouds frequently have Kelvin-Helmholtz instability at the top, which is caused by velocity shear within fluids. This instability is less common at the base of clouds. So what could be the source? We don't know yet. But the authors of the earlier 2017 paper suggest that this instability could propagate downward from the top of the cloud, if the cloud is thin enough. Perhaps the reasons are different each time. According to the scientist who captured this time-lapse, gravity waves were moving through an inversion beneath an elevated region of instability. You've probably seen an inversion, which occurs when clouds or even smog become trapped beneath a layer of hotter air. Thunderstorms were predicted, but because the inversion prevented thunderstorms from pulling inflow air from near the surface, they instead pulled from above the inversion. The gravity waves moving through the inversion generated enough lift to form a strong updraft that moved in phase with the gravity wave's peak. The increased lift from the updraft increased the amplitude of the wave, making the Asperitas cloud very visually appealing. This internal instability appears to disrupt the weak oscillatory activity at the base, resulting in a rough, choppy appearance, regardless of how it occurs. So when you think about it, the winds and currents that cause the choppiness of the ocean on a stormy day aren't all that dissimilar to the chaotic forces that scientists believe cause instability in an Asperitas cloud. Complex fluid dynamics are at work in both cases, resulting in eerily similar characteristics. Nature does not repeat itself, but it frequently rhymes. So there you have it, a primer on one of the most recent and least understood cloud types. If you're interested in this, you should keep an eye on the sky and take photos of anything interesting you see. Who knew we'd still be discovering new types of clouds? What else is out there that we don't know about? And who knows? You might be involved in the next scientific breakthrough. Isn't it amazing what happens in the world around us that we may take for granted? Have you ever wished you could see the world through for today? Thank you for spending some time with us. If you found this video interesting, make sure to hit the like button and the notification bell and subscribe to our channel to get access to more interesting videos from us. Till next time.